The lower BJT operates in the shaded region of the topology as shown in the below figure. If V1 is A cos omega mt and V2 is B cos omega ct, then V out will be proportional to. We know that V out is nothing but GMRD. Here GM is nothing but dou I divided by dou V1 here, which is proportional to V1. Hence I is V1 square. Hence here from this V out is proportional to GM. GM is proportional to root I. So GM is proportional to V1. So this is V out by V2 is this is gain. Okay. So now we have to find out V out. So V out is nothing but V1 V2 proportional to V1 V2. So which is nothing but A cos omega mt B cos omega ct, which is nothing but proportional to AB cos omega m omega ct plus cos of omega m minus omega ct. Hence option B is correct. An intrinsic semiconductor with energy gap of 1 electron volt has carrier concentration N at temperature 200 degrees Kelvin. Another intrinsic semiconductor has the same value of carrier concentration at a temperature 600 degrees Kelvin. What is the energy gap value for the second semiconductor? Here Ni is proportional to exponential e by kT. So Ni is N here. So N is equals to one is equals to e power 1 by K200 divided by e power Eg divided by K600, which is equals to e power minus Eg 600 K is equals to e power 200 K. That is Eg by 600 K 1 by 200 K. Here Eg is 3 electron volts. Hence option C is correct. The open circuit voltage and the resistance of a microphone are 15 millivolts RMS and 100 kilo ohms respectively. An amplifier with input impedance of 50 kilo ohms is used for amplifying the microphone output to deliver 2 watt power to a load of 8 ohms. What is the voltage gain of the amplifier? Here, suppose if we are representing a microphone with its equivalent circuit like 15 millivolts RMS, 100 kilo ohms, and this is 50 kilo ohm, an amplifier whose input impedance is ohms. It is delivering a load of 8 ohms. It is delivering a 2 watts power. Means power output is nothing but 2 watts, that is Vrms square divided by 8 ohm, that is Vrms is 4 volts. So input Vrms is 15 millivolts divided by, this is 100, So 150 kilo ohms into 50 kilo ohms, 5 millivolts. So gain of the amplifier required is 4 by 5 into 1000, which is 800. Hence option A is correct. Output Y for the given circuit shown in the figure. Here suppose I am assuming at this node X, this is 0, means here also X. So here this is the exclusive R. So X 0 bar plus X bar 0. Hence it is also going to be X. If both are X, Y is going to be a 0 always, because whatever may be the combination we are getting here, here also we are going to get a same. So option C is correct. The dual slope A to D converter uses a reference of -6 volts and a 1 MHz clock. If it uses a fixed count of 40, then what will be the maximum conversion time? Here conversion time we can indicate like this. Suppose this is the total conversion time, which is indicated with T. It includes two parts. Suppose this is T1, this is T2. Here T is nothing but T1 plus T2. Here T1 depends upon time to count, that is 40 divided by 1 into 10 power 6, that is 40 microseconds. T2 depends upon the maximum output, that is all bits, means 6 bits are goes to 1, that is 63 divided by 1 megahertz, which is equals to 63 microseconds. 63 is nothing but 11112. Hence total period is equals to T1 plus T2, that is 103 microseconds. Hence option B is correct. When a 15 amps current is applied to a particular diode, it is found that the junction voltage immediately becomes 700 millivolts. However, as the power being dissipated in the diode rises its temperature, it is found that the voltage decreases and eventually reaches 580 millivolts. And what is the thermal resistance of the diode? We know thermal resistance is power dissipated divided by power dissipated, and this is temperature change. Here the voltage drop is equals to 780 minus 700 minus 580, which is equals to 120 millivolts. dV not by dt means the diode change in the diode voltage with respect to change in temperature is, this is 2 millivolts per degree centigrade. There is a 120 millivolts change, means the temperature must be 60 degrees. Change in junction temperature is 60 degrees centigrade. The power dissipated is 580 into current, that is 8.7 watts. Hence thermal resistance is 8.7, 60 degrees centigrade by 8.7, which is 6.9 centigrade per watt, which is option A is correct.